Hundreds of thousands of Americans lost electricity, government offices and schools closed, and flights were cancelled as winter storms engulfed the US southeast and mid-Atlantic states.
The entire Earth is frozen solid. Imagine that. It's a scary thought, but scientists warn it's happened before. This deep freeze is triggered by Milankovitch cycles, which are shifts in Earth's movements and tilts. These shifts mean less sunlight and colder temperatures, possibly setting us up for another ice age.
The Pacific Northwest can expect a snowy weekend with blizzard-like conditions and an estimated 6 to 12 inches of snow.
What if we're heading straight into a global deep freeze? Let us reveal how close we really are to this deadly future. Exploring the Ice Age's secrets. Think about how each part of the planet gets more or less sunlight at different times of the year because of this tilt. This tilting determines if a region will have warm or cold weather, resulting in different seasons. Around March 21st and September 21st, the sun lines up directly with the equator. When this happens, we get almost equal amounts of daylight and nighttime all around the world. These days mark the start of spring in the Northern Hemisphere and autumn in the Southern Hemisphere, and the opposite happens in the other half of the year. Yet, as we approach these balanced days, scientists have discovered a shift in Earth's rotation that could disrupt our seasons and climate. Now, consider what happens on June 21st. The Northern Hemisphere tilts toward the sun, leading to the longest day and the shortest night of the year. This is the summer solstice. During this time, sunlight is most direct, bringing the heat of summer. On the other hand, December 21st marks the winter solstice when the Northern Hemisphere tilts away from the sun, creating the shortest day and the longest night, bringing the cold of winter. The Southern Hemisphere goes through the exact opposite during these solstices. But here's where things get even more interesting. The planet's tilt and orbit don't just shape our seasons, they also affect how intense and long these seasons can be, especially with the impact of climate change. Human activities are making weather more extreme, with summers becoming hotter and lasting longer. This understanding of how our planet works is crucial as we prepare to adapt to a warming world. Yet this isn't the end of the story. The real challenge lies in how these changes might spiral further. The changes between hot summers and cold winters, along with more unpredictable weather, are reshaping our world in many ways. From the way nature behaves to how we grow our food and live our daily lives, everything is being affected. As climate change becomes more significant, it's more important than ever to understand how the seasons work. We need to think about how these changes could interrupt the normal flow of seasons and what that means for all living things on the planet. This tilt is also why we have solstices and equinoxes, which mark important changes in seasons. The summer solstice, around June 21st, happens when the northern half of the planet is tilted directly toward the sun. This day has the most daylight and the shortest night, which is why summers are so hot in that part of the world. But this isn't the worst part. While the northern half basks in the heat, the southern half endures its coldest time of year. Around December 21st, the winter solstice brings the longest night and the shortest day to the northern half, making it the coldest season, while the southern half enjoys its warmest season. Equinoxes, around March 21st and September 21st, are when the sun is directly over the equator. During these times, both halves of the planet get equal amounts of daylight and darkness. This balance signals the beginning of spring in one half and fall in the other. Let's dive deeper as the Earth's dance with the sun changes our seasons. The seasonal shifts you didn't expect. But here's the catch. Despite the tilt staying the same, changes in the climate are making these seasons more intense and unpredictable. With global temperatures rising, we are seeing longer, hotter summers and shorter, milder winters. These shifts are changing natural habitats, farming practices, and weather patterns all over the world. And as these changes become clearer, understanding how the tilt affects the seasons is key to adapting to our new climate reality. The way seasons change also varies greatly depending on where you are in the world. While many regions experience the typical 4 seasons, others have unique seasonal patterns due to their location. In temperate zones, which are found between the tropics and the polar circles, the year is divided into 4 distinct seasons. These areas, which include large parts of North America, Europe, and Asia, each have their own unique climate patterns shaped by their geography. Throughout the year, we all notice changes in the temperature and weather. In spring, the weather gets warmer and plants start to bloom. Summer brings longer days, lots of heat, and plenty of sunshine. In autumn or fall, the air cools down and leaves start to fall from the trees. Winter is the coldest season, often bringing snow and ice to many areas. These changes in the seasons happen because of the tilt as it orbits around the sun. In places with mild climates, the amount of sunlight shifts, changing the temperatures and creating the seasons. For example, during the summer solstice in June, the northern part of the planet tilts toward the sun, leading to longer days and warmer weather. On the other hand, during the winter solstice in December, the northern part of the planet tilts away from the sun, resulting in shorter days and colder temperatures. But what about places near the equator? In those areas, like much of Africa, Southeast Asia, and Central America, the concept of 4 distinct seasons doesn't apply. Instead, these regions usually have 2 main seasons, wet and dry. The wet season, or monsoon season, brings heavy rain, high humidity, and rapid plant growth, which are all crucial for farming and water supply. The dry season is the opposite, with very little rain, lower humidity, and often hotter weather. These seasons are shaped by the movement of a low-pressure zone called the Intertropical Convergence Zone, which shifts with the sun. When the ITCZ moves over an area, it brings rain for the wet season and then moves away for the dry season. Now think about the polar regions, like the Arctic and Antarctic. Here, the seasons are very extreme and mainly depend on how much daylight there is. In the summer, called the polar day, the sun stays up all day and night, creating endless daylight that can last for months. But in the winter, or polar night, the sun doesn't rise at all, and the area remains in darkness for months. But this isn't the whole story. Climate change is beginning to shift the timing, strength, and characteristics of these seasons worldwide. For example, as global temperatures rise, summers are getting longer, winters are getting shorter, and rain patterns are becoming less predictable in tropical regions. In the polar areas, the melting ice is changing the lengths of the polar days and nights. These changes have major effects on wildlife, farming, local traditions, and human communities, highlighting how important it is to understand and adapt to these changing seasonal patterns. Now let's see how the Earth's steady tilt shapes our world. The role of the Milankovitch cycles. The Southern Hemisphere has opposite seasons because of the same tilt. So, when it's summer in the Northern Hemisphere, it's winter in the Southern Hemisphere. Also, during the equinoxes, around March 21st and September 23rd, neither hemisphere tilts toward or away from the sun, which means almost equal daylight and darkness everywhere on Earth. Now, here's something interesting. Earth's tilt doesn't change as it goes around the sun. It always points in the same direction, towards the North Star. This is why we have seasons. It's not because Earth gets closer or farther from the sun. When parts of the Earth tilt toward the sun, they get more direct sunlight, making them warmer. But when parts of the Earth tilt away from the sun, they get less direct sunlight, and it becomes cooler. Another thing to think about is the length of the days, which also changes with the seasons. In summer, because of the Earth's tilt, the sun takes a longer path across the sky, so the days are longer. In winter, the sun takes a shorter path, so the days are shorter. This change in day length and how much direct sunlight each area gets affects the temperature and weather in different places. If we look at Earth's climate over a longer period, we come across something called Milankovitch cycles. These cycles, named after a mathematician from Serbia, help explain how Earth's climate changes over tens of thousands of years. The cycles have 3 main parts: eccentricity, obliquity, and precession. Eccentricity looks at how Earth's orbit changes shape over time, from more circular to more oval-shaped. This change affects how far Earth is from the Sun and how much sunlight we get. The tilt of the Earth, which changes between 2 and 24 degrees over a 41,000-year cycle, is a big factor in how we experience seasons. A larger tilt makes summers and winters more extreme, while a smaller tilt softens those changes. Earth's axis also wobbles, a movement called precession, which takes 26,000 years to complete. This wobble changes the timing of the seasons and can make them more or less intense depending on where Earth is in its orbit. Recent progress in studying the Earth's climate comes from things like ice cores, sediment samples, and advanced climate models. These tools help us see how natural cycles in Earth's orbit have caused major climate changes, such as ice ages, in the past. But the climate shifts we're seeing now aren't just due to natural cycles. Human activities are also playing a big part. Together, these factors make our climate more complex, showing how Milankovitch cycles are still important in today's climate studies. Another factor is Earth's orbit, which isn't a perfect circle. It changes shape over thousands of years, becoming more or less oval, a change called eccentricity. Right now, the orbit is almost a circle, with an eccentricity of about 0.0167. Even though this number seems small, it still affects how much solar energy Earth receives and can lead to long-term climate changes. Next, we explore ancient rhythms that still guide our climate today. Earth's changing orbit. When Earth's orbit becomes more elliptical, meaning more oval, the seasons become more intense, which affects temperatures and ice coverage, especially in the Northern Hemisphere. Modern science, with the help of data from space missions and climate models, helps us understand and predict these changes better than ever. For example, NASA keeps track of Earth's orbit and climate to help monitor these shifts. But that's not all. Earth's axial tilt, which is about 23.5 degrees right now, also affects the climate. The tilt changes how much sunlight different parts of the planet get, which is why we have seasons. Over thousands of years, this tilt slowly changes due to something called axial precession. Even small shifts in the tilt can lead to big climate changes, like the start of an ice age or stronger seasonal variations. These natural cycles combine in complex ways, creating a web of factors that influence how our climate changes over time. Right now, Earth's orbit is more circular, which gives us a relatively stable climate. But in the future, as the orbit becomes more elliptical and the axial tilt shifts, we could see bigger temperature swings and changes in ice cover. This ongoing process, along with human impact, continues to shape our planet's climate in important ways. The Milankovitch cycles are a group of slow, natural movements of the Earth that affect how much sunlight different parts of the planet get over thousands of years. These cycles have a big impact on our weather and climate. The three main cycles are eccentricity, obliquity, and precession, each one influencing Earth's climate in its own way. First, let's look at eccentricity. This is about the shape of Earth's orbit around the Sun. Earth doesn't orbit in a perfect circle. Sometimes the orbit is more stretched out, and other times it's more round. This change happens over about 100,000 years. When the orbit is more stretched, the seasons become more extreme, because the distance between Earth and the Sun changes more. Summers might be much hotter, and winters could be much colder during these times. Next is obliquity, which refers to how much Earth tilts on its axis. This tilt changes over a period of about 41,000 years, going from about 22 to 24 degrees. The angle of the tilt affects how much sunlight hits different parts. When the tilt is greater, summers become hotter and winters get colder. When the tilt is smaller, summers are cooler and winters are warmer. This tilt also affects ice ages, as a greater tilt can cause ice sheets to grow or melt. Imagine a spinning top that wobbles a little as it slows down. This wobble changes when it is closest to the Sun, which can shift the timing of the seasons over about 26,000 years. This means that sometimes winters might be milder or summers could be wetter, depending on where you are. Scientists have figured out these cycles by studying ice cores and ocean sediments, which hold clues about how its orbit and tilt have changed over hundreds of thousands of years. These studies show that when its orbit or tilt shifts, it can lead to ice ages or warmer periods. Even slow changes have big effects on our planet's future. The subtle shifts shaping our climate future. But here's the catch. This isn't even the most surprising part. The changes happen so slowly that most of us won't notice them during our lifetimes. Yet, they play a huge role in shaping its long-term climate. These cycles may take a long time to unfold, but they have a strong influence. They've been a key factor in shaping its past and will continue to influence its future climate as well. Recent studies, using advanced satellite technology and research into ancient ice, show that its tilt is slowly decreasing. This gradual change is important for the future of its climate. If the tilt continues to drop, we might experience cooler summers and warmer winters, which could influence how ice forms and change weather patterns in the long run. But that's not all. This shift could also impact ecosystems and human life all over the world, not just in the polar regions. The environment we rely on may change in subtle but meaningful ways as this process continues. This change could spread across the world, affecting weather and natural environments everywhere. It shows just how connected its weather systems really are. Scientists are also looking at how its tilt works with other parts of the Milankovitch cycles. These cycles include things like the shape of its orbit around the sun and the way it wobbles on its axis. Together, these cycles can lead to big climate changes over thousands of years, helping us understand things like ice ages. Depending on how these cycles line up, they can either make each other stronger or weaker, leading to complex climate patterns. Understanding how these cycles work is important for predicting future climate changes. Right now, the tilt is slowly decreasing, which could balance out some of the warming predicted by other climate models. But human activities, especially the release of greenhouse gases, are still having a major impact on the climate today. In many cases, these human-made changes are bigger than the natural cycles. As science continues to improve, keeping track of these cycles will be key for making accurate climate predictions and figuring out how to deal with environmental changes. What are your thoughts on how human activity compares to natural cycles in impacting climate change? Like, comment, and subscribe for more.